Okay, as you can see from this AutoCAD drawing, okay, this is a sample of building, and this is the sample of one group will get lah. Okay, as I mentioned earlier, we have 11 type of building that I will give to 34 group lah. So mungkin maybe some group, maybe 3 group will get the same project lah, because we have a 34 group and we only have 11 type of project. So this figure that you have seen in your screen actually is one sample lah, one sample of the building that you need to work out after this for your project. Okay, and this is for what we call it, pejabat pentadbiran lah, pejabat pentadbiran. So what I'm trying to talk today is this is complete design electrical lighting system that has been complete design. So actually you will get a blank drawing after this. Okay, so this is already complete. After this, I will give a blank drawing. Okay, let's say blank look like this. So there's no lighting for this room, right? So you will get look like this lah. Okay, so you only have a blank room. You only know, okay, this is the bilik pengarah. Okay, director room lah. So what you should do is you need to design, you need to find how many number of lighting should install in this room. So right now, if I ask to you, do you know how many number that require to install here? Ada siapa-siapa tahu tak berapa biji lampu sepatutnya ni install sini? Anybody? Kumaran, do you know how many numbers should install here? Kumaran?
4 kot sir.
Oh, 4 sebab nampak saya delete tadi ya. Kan? Okay, but actually this is the situation. Okay, I just make some introduction for what we should do today. You should understand. Okay, because after this I will give a blank document and you should calculate. First you need to calculate, and after calculate you need to draw lah for complete building. Okay, symbol you already learn, and you have already have a symbol for first lab, right? And tomorrow, or not tomorrow, for my class lab in Friday, okay, we will have a detail lab on how to draw the layout drawing for lighting. Okay, so this is what we try to learn today lah. So based on this type of room, okay, and then based on the dimension of room, and then the another thing, we need also the drawing from for this drawing. Okay, that the second issue. The second drawing, actually we need to have a view from side of the building in order to know the height of the building. If you don't have the height of the building from the side view, so we need to ask the architect lah. So how many height of the building? So normally standard building we use 3 meters lah. Okay, clear? So we have a lot of type of lighting, and this is just one sample that previous engineer just draw for this building. So I hope you can choose your own lighting for your project. Okay, so I close this one. So the detailed project you will perform on your lab lah and your project. PowerPoint. Siapa nampak saya punya PowerPoint tak? Mana PowerPoint saya? Word. Okay. Alright, so we start our chapter 3. We waste about 30 minutes. I'm so sorry for apa masalah, tak tahu hari ni. Okay. Bismillah. Okay, we start with definition. Okay, in terms of luminaire, okay, it is the apparatus which control the distribution of light from the source lamp and include the required fixing arrangement, connection and protection. So the luminous, okay, is a lamp, actually lamp lighting system. So normally we call it luminous, and normally the luminous is complete with the fixing arrangement. So how to arrange the lighting into one row, okay, and then how does the connection we need to do for the lighting, and also we need to know the protection for the lighting. So the luminance is include all of these things. Okay, now just very simple the definition. And then luminous flux or light output, the total quantity of the light emit per second by light source. So we calculate or the unit of the lighting of the light we measure using lumen LM lumen. Okay, lamp lumen, okay, LM the unit. So this is the quantity of light emit by light source. Okay, so we have one lamp, and then from the lamp that light emit by this source of lamp, we call it the lumen. Okay, and then the luminous efficiency. So this is the ratio of the light output to the energy output. Efficiency. Okay, efficiency, luminous efficiency. So this is output from the ones of the lamp. So which is we measure it and using lumen per watt. Okay, lumen to the energy input per watt. So how many watt from this lighting, and then how many output, kecerahan dia, how many output of the light produced by the lamp. So this is the measurement of the luminous efficiency. And then second thing is a luminous flux density. Okay, or lighting level. Luminous normally we call it lux bahasa dia. Okay, luminous flux density or lighting level. So but normally we call it by lux okay, when we talking about lux. So I hope you know lah. Okay, that is the luminous flux density over lighting level. Okay, or we also known as the illuminance. Okay, illuminance. And normally we measure the illuminance using this item we call it lux meter. So the lux meter, one lux equal to 1 lumen per meter. That's unit lah, unit. So no problem about this one. Tak penting, just for your information je lah. And then another thing is luminous intensity. Luminous intensity. This is a measure of light power of source is given direction. So the unit is candela. Okay, the direction. Okay, direction here. So intensity, let's say we have this one light, and then the direction of the lighting conform straight away to the floor, right? So the unit is CD, candela. And then we have luminance, L, a measure of intensity. So just now we have intensity, and then for luminance is intensity of the light per unit area. So we have the intensity, and then we have area. So now we have the lumens, which is luminance is candela over per meter. So it means it's reflect to the size of the area lah. And then illuminant, E, the luminous flux density that surface of or working plane. So the unit is lux. So this term, this is the important term lah that you need to remember or you need to understand, because now we are playing with this thing lah. Okay, your design should be include of your design to of the lux. Okay, luminous intensity of the luminance or lamp in special direction and normal show in the form of polar curve. Okay, and the luminous flux density at the surface working plane. So the surface working plane meaning that in every room you need to understand what does function of the room. Let's say we just see just now the director room. So we know that the director room is working plane confirm. The director will working on the desk, right? Takkanlah director working on the floor. So the director confirm will work on the desk. So based on that, we know that we have the level of the desk. Then we need to calculate. We need to consider the level of the desk compared to the toilet. The toilet, so what's the working plane on the toilet? So there's not require a table, right? So the light is from the ceiling directly to the floor. Okay, so number one, you need to know the function and the function of the room. Okay, for every room, you just see the name of the room and then you need to identify what does working plane for this room. Okay, because some room it will not given to you the table and the furniture, so you need to decide by your own. Okay, you are designer, you need to make some decision based on that. So okay, and then this is the polar curve. So polar curve normally for every lighting that we are design and we are plan to install in our project should have this polar curve, because from this polar curve, or we call it a schematic, this one you can see from here. Tak nampak okay, so you can see this one is polar curve. So you can see here this is the source of your lamp, then this is the curve. So from here we know that for this lamp, their illuminant is cover up to 45 degree. So meaning that from the light source, so the luminous it cover to the light only cover up to 45 degree. So if you want to make a very wide of the angle of the lighting, so you need to find the lamp that possible to produce lighting up to 75 degree. So that's the way lah. Okay, and sometimes or most of the lighting right now they just up to 30 degree saja tau. Okay, this is the focus lighting. Okay, and then the shape of the polar curve indicate the way the way which the luminaire control the light distribution. So from this one, let's say is so 45 degree so you need to understand the polar curve. So once you understand the polar curve, so now then you can plan how many the distribution of the lighting into the room. If not, if you not consider all of these things, so your design will have some place very light, some place very dark. So it's not average. Okay, so you need to consider all of these things. Okay, and then the light source we have three, which is number one is incandescent, luminant, and electro luminance. Okay, so for the incandescent, normally it's depend on the heated this menthol, right? The lamp, very old type. I believe not much right now using this type, but still have. Okay, and the intensity increase and the appearance become whiter as temperature increases. So this still use the gas inside here, and it depend on the temperature. So once the temperature is high, so the luminance become brighter. So they call it temperature radiation. So number 2 is luminant. Okay, first is incandescent, second is luminance. So luminance is normally we call it fluorescent lah. Okay, it work based on emission of light. Okay, to type electric or gas. Okay, and fluorescent. This one is fluorescent. Okay, and this one is PLC. Okay, number 3 is Electro Luminance, which is this is the latest one. Later one we use normally we call it LED, and I believe most of the project use this type of the what we call it, the Electro Luminance, because of we use the electronic semiconductor device. Okay, your house using what type? LED ke fluorescent? Muslina, rumah kamu pakai LED ke fluorescent ataupun pakai incandescent lagi? Which one?
LED sir.
LED ya? Terang bagus ya. Sebab latest kan. So kalau if you want to got a lot of saving, so we prefer LED lah. Okay, LED type. Because the lighting, the output of the lighting we got same, but the electricity we got the different. Very about almost 50% we can save. Okay, so lamp type. Lamp is very simple lah. Electric energy into the light. So lamp type, okay, incandescent, gas, discharge lamp, and electro luminance, which is LED. And then under gas discharge we have HID, MV, and MH, and HPS. So normally this type is for outdoor lighting, and for stadium, and for the outdoor, normally for outdoor. And this model very consume a lot of electricity actually. Okay. And then based lamp type by standard classification. Okay, we have incandescent, fluorescent, HID, same LPS, and LED source, same thing lah. Okay, lighting system. Okay, lighting consists of a lamp. Okay, normally in what you will see on the when you open the lamp. Okay, let's say for fluorescent, first thing you will have the lamp itself, and then you will have a ballast. Okay, and then you have housing lah. Kan, let's say we have one lighting, so normally you will have the ballast here, and then the casing lah. This one is casing, and then we have a lighting here, right? Kan, lighting. And then internal wiring confirm from ballast connect to this one, the lighting. And then divisor lever. Some lamp type they have divisor, some don't have. Divisor is something is cover the lamp. Okay. Maybe after I show the picture of this lamp. And then the lighting system, okay, we have a luminaire and control system. So control system is on how to switch on how to control, maybe we have dimmer and so on. And then when we're dealing with system environment, so it have a ceiling, wall, and floor, and room object. So this one we need to consider also, since the environment also affected the lighting luminance. Okay, kecerahan dalam bilik tu is affected by the ceiling, wall, and floor, and also room object. So that's why during our calculation after this, we will take consideration also the value of ceiling, wall, and floor. Okay. Okay, number one, we try to go very fast related to the theory. After this, we try to focus on the calculation. Okay, the incarnation light. Okay, incarnation light is produce light by using electric current to heat metallic filament. And yeah, this one is a metallic filament. Okay, the tungsten filament is used because it's high melting point. Okay, and low rate of evaporation at high temperature. Okay, and the filament is coiled to shorten the overall length to reduce thermal loss. Okay, so this incandescent light is based on the temperature. Okay, and then it's controlled by the glass. Okay, the glass of this is the glass, and then inside of the glass they have a gas, normally argon. Okay, and then from this filament will be heated, and from that the heated will be interact with the gas, and then from that it combust the light we call it. Okay, and then this is the shape of the incandescent light. They have a lot of type, and it depend on the code lah. Okay, sometimes when you want to find maybe this model, so you can ask the supplier, okay, PAR type. So PAR type is parabolic aluminium. Okay, pair. You need to know lah. Okay, the code of the shape of the incandescent light. Okay. Alright. Okay, and then number two, we have a tungsten halogen. Normally this one, this halogen, if you can see here, inside here, kan? The sample. Okay, the quartz tungsten halogen lamp is another type of incandescent lamp. Okay, this is also under incandescent lamp. Okay, the conventional incandescent lamp lost filament material by evaporation with deposit on the bulb wall, leading to bulb blackening and reduced lamp efficiency during the life of the lamp. When a halogen element is added to the field gas under a certain design condition, chemical reaction. Okay, so the concept same, but it use a quartz glass for the halogen. Halogen will produce more light compared to the incandescent, normal incandescent. Okay, that's why some of the car they use a halogen lamp, because the halogen lamp will produce very what we call it, very light of the lamp. Okay, and then this the shape of the halogen. Okay, this is just for your information. So normally we this is the what we call it model type. We have MR16, T3, T6, T8, T6, T10. Okay. It depends on the shape. Maybe after this, if you want to buy the halogen light, you just call it, okay, I want to buy T3 halogen. So the supplier know which model that you want to buy lah. Compared to you just ask, I want to buy a halogen lamp. So the supplier will be confused which one, because there are a lot of type of the halogen bulb. Okay. Okay, and then under incandescent also we have halogen power. Halogen power, which is it depends the reflector, the shape of the reflector. Okay, this one the reflector. This is we call it by power. Power is a parabolic aluminum reflector. So this is only the reflector. So whatever light produced by this halogen capsule will be transmit to the reflector, and then from the reflector will distribute the light lah. Okay, so this is the concept lah of the power lamp halogen. Okay. Okay, and this one also aluminium silver. Normally they use aluminium for the reflector. Kan, yang you nampak, if you can see, normally you will have find the chrome one, right? So that's the coating reflector only. And then normally power lamp is used for directional lighting and highlight also light. Most common power 38 and other size including 30, 20 and 16. And then for halogen power lamp, we use halogen capsule instead of a tungsten filament. Okay, this is some sample that available in the market 45, 65 and 90 watt. Okay, but right now I believe that they have a lot of model right now. Okay, so normally they apply on the downlight, accent and outdoor light normally. Okay, so even but due to the latest technology, all of this type of the lighting, we are not apply power yet. We convert into the LED. Okay, so advantage halogen power. Okay, energy saving up to 40 to 60, and then whiter light and then constant light output. And then but the limitation expensive kan, mahal sebab the cost of the gas and so on. And then the assessment halogen power provide energy saving which outweigh the lamp price difference less than a year. So that's the issue lah. So halogen power lamp provide better quality light. And then we have number 2 gas discharge lamp, which is low pressure discharge, normally fluorescent lamp lah. This one kan, I believe most of the house using this model right now kan. So this is fluorescent. So fluorescent is a low pressure mercury electric discharge lamp. If you try to pecahkan break this glass of the lamp, so you will have a whiter gas macam tepung tu. So that's the mercury actually, mercury or argon gas dalam tu. So the glass tube filled with mixture argon gas ni, this one argon gas and mercury vapor at low pressure. When current flow, when we supply the current here, so it will be ionized between the electrode and it emit the UV from the mercury arc. Okay, so from here, it will produce the arcing here, mercury. So from the mercury arc, it will radiate the UV. Okay, so the UV then they convert to visible light by fluorescent coating. So here under this one we have fluorescent coating. So this fluorescent coating emit by the mercury arc tu, so it will produce the light lah. Okay, and then it will connect through the ballast which provide the necessary starting voltage and operate current. So the ballast will normally is connect before this one. So ballast will provide the starting voltage only, right? When you switch on, so the ballast will increase, will step up the voltage for the light to make sure the mercury are able to produce the arc into the lamp tube. Alright, so settle on the introduction of the lamp type. So very simple thing lah, just for your information only. So now we try to go into calculation of lighting. Okay, so normally we have 3 type of lighting. 3 type, which is number 1 we call it by inverse square. So inverse square, if we were to illuminate surface by means of a lamp position vertical above it. Okay, let's say vertical above it. Okay, measure the illuminant at the surface. Okay, we measure at the surface and then move the lamp twice as far away. We move it The illuminant now measure would be 4 times less. Kan macam tu. The illuminant 4 times less in A. Alright. So this is the concept of inverse square lah. Kan. The value from here to here is 2 times lah. 2 times. Katakan 2. So now it's become 4. Okay. But normally we don't use this method lah. Normally we don't use this method only. And now I just shows the available method to calculate the lighting requirement. So this very simple lah, simple type, kan? So semakin jauh kita far we move the source from the surface, confirm it will separate to a big space, kan? So very simple lah. Okay, even this angle is depend on the lighting that we have discussed before. Is depend on the polar curve, right? So let's say this one is 45. So the 45 from the lamp is same. We cannot do anything. What we can do is we try to move it to the upper level, and then the separation of the light will be bigger lah, kan? But confirm what we have lighter here, so the light at here is not same with what we have at here. Okay, if we move away 3 times, this the continuous lah. Okay, if we move away 3 times of the radial distance, would be 9 times lah, because the formula d square, right? So it will be seen that the illuminant of the surface is governed by the square of the vertical. So I divide by distance squared. Okay, if you got the question, so you can use this very simple formula to calculate the illuminant required. Okay, and then number 2, we use the cosine rule. Cosine rule also famous before this. Okay, so cosine rule, cos and sine lah. Normally cos and sine, right? Cos we use triangle ni, kan? I believe most of you still remember on the mathematics, kan? Point X, let's say we want to get, okay, this is the lighting we put here, and then this is the straight. It's further from the source, then is point Y. Okay, this is point Y, and this is the source. So this is straight away, and then this is the point X. The illuminant at this point, okay, is therefore less, confirm lah, kan? Illuminance from here is less lah, because this is direct light, direct from the light, right? This one is based on the what we call it, apa ni, sudut ni. Okay, in fact the illuminant at X depend on the cosine of the angle, angle theta, this theta. So it depend on the angle. So the far X from the angle, so the low illuminant will be get there. So how to determine? So you can use this formula in order to find which location of X that are possible to allocate. Let's say you do not know which let's say you have this room, okay? You have a room, okay? And then you want to put light here, and from here you need to know what does the angle value. So refer to the lamp data sheet, especially the polar curve. Okay, the polar curve will provide the angle, right? So let's say we just refer back to the previous data sheet, set 45. So the angle is 45, and from that you can calculate lah using cosine rule, kan? So L multiplied by cos over 3 by theta 45, and then D over 2. This one, D squared. So you can get the illuminant value, okay, at X ni. Very simple, right? So you can use maybe sometime exam question will give you this length. plus this length, and you do not know the value. Or normally we will give the h, and then you need to find the d. So that's only mathematical. So to find this value, so you can use the theorem Pythagoras kan. Let's say we give this theta, and from the theta you can use hypotenuse and so on kan. So you can get value of d, or here value here instead to find value of x. Okay. This example you can try by your own lah. Very simple thing, very simple. Okay, I'm not stressed on this part. So okay, and this is the second example. Now we're going to the last method of the lighting design, which is this is the method that you need to use for your project, for your assignment, and also for the exam lah. So please make sure you are capable to know to use this method. Okay. So in lighting design, an electrical engineer has to ensure that design adequate lighting, kan, confirm lah. Let's say you have the building, so you need to make sure that your design possible to provide adequate lighting into every room. So the level of illuminance attained must follow the requirement of IES code or JKR. So I believe that I already upload the table of whatever related to the lighting system into your Google Classroom. I hope you can download it now lah. Bukan now, after this kah? Ataupun I believe that you already downloaded it. And then you can open it, and we will try to use it. Okay, how to use every table that I provide to you. Okay, so in Malaysia we follow two standard, which is IES and also JKR standard. Okay, for every room, okay, let's say for your study room, so how many lux require? So we do not know, kan? So that's why JKR and IES, okay, IES already published the standard lux requirement for every single type of room. So easiest to us that we just follow that value. Let's say for the office, the lux is 300. So we just use it 300. On how to achieve that 300, so we apply into this formula. Okay. So first step to calculate the lighting, okay, using the Lumen method, okay, you need to find the room index first. So what does what is a room index? So room index is related to the room dimension and used when calculating the utilization factor and other characteristic of lighting installation. So apa benda ni kan? So room index, okay, K, normally the unit is K. So you need to calculate based on this size of room. Let's say you have a director room macam tadi, just we saw on the AutoCAD drawing, director room. Let's say this size is 10 and this is the 6 meter. And okay, for your information also, maybe you will see on the AutoCAD the value is 1000 in 1000 value, right? Maybe lah. Okay, but in calculation we are measured on the meter. So you need to convert it lah. Okay, so your drawing is measured on millimeter. So our calculation all on meter. So please convert lah. Let's say for you got 6000 here. So 6000 is equal to 6 lah. Okay, clear. So length of room, width of room, and then HM. So HM is the mounting height of luminaire above the working plane. So HM, this HM. So you need to know the height, okay, of the working plane for every room. Just we discussed earlier for the, let's say for the director room. So the director will work on the desk, right? So that level of desk we are consider the working plane. Dia bekerja atas meja lah, kan? Dia buat kerja atas meja. So the light from the ceiling will distribute into the working plane. So in this case, so the desk lah, level, desk level. So when we dealing with the desk level, so you need to calculate lah the number of HM. Okay, let's say this your lamp here, okay, and then this level of the desk. Okay, so you need to calculate. Let's say normal this one is 3 meter, kan? The 3 meter from here to here, 3 meter. But we have desk and this lamp only calculated, the HM is calculated from here to here saja tau. From lamp to this working plane. So we have complete is the 3 meter, and then we need to subtract the level of the desk here. And then for your information also, please remember also, the height of the desk is 0 point apa? 0 point apa? Tinggi meja. Supaya ingat diploma. The height of a standard desk, how many meter? 0 point?
0.7.
0.7. Okay, good. Okay, please remember that value. Sebab normally we don't provide the value of the desk, and we consider that all of the engineers will know because the level of desk is standardized worldwide, worldwide 0.7. That's why kalau you pergi beli mana-mana meja, you balik dia sama je kan. You see this, you will have the same level. Except you build by your own kan. So you will have a different level. Okay, settle lah. Number one, you need to calculate the value of K. So you have length, you have width. Let's say you have length, you have width. You multiply, let's say for this case, 6 multiplied by 10. And then HM, so let's say 3. So 3 minus 0.7. So you get 2.3 je lah here. And then multiply by length. Okay, length you have 10 plus 6. Okay, macam tu. So you will have the value of this K lah. So saya tak tahu, you try calculate. If you, in this case, berapa you akan dapat? Maybe 1.9 kan? Ada tak try calculate? Length there we have length 10. This one 6. Kan? Betul tak? Dapat 1.9. Dapat tak? Ni calculate tak ni? Okay, dapat tak? Dapat tak 1.9? Senyap lah buat ni. Boleh dapat tak value? Anybody here? Hey.
Yes, sir.
Dapat apa? Yang calculate dapat apa? 1 point? Kau tak ada calculator ni? Tak. Let's say I just give one example je ni. Siapa cakap ni? Nelly. 10
Yes, sir.
Berapa dapat? Kau line saya sangkut-sangkut ni. Risau pula.
1.63 sir.
1.63.
Ya.
1.63. Agree ya? All class got the same same answer
Yes, sir.
Betul, sir.
Okay, good. So this is the example on how to determine the room index. Very simple. Okay, so for every room you need to calculate now. So let's say I just share the AutoCAD drawing. We have a lot of a room, so you need to find for every room index, and after that, from that you need to go for second thing, which is this is the formula on to find the number of lighting required for every room, single room. So this formula we call it Lumen Method. Okay, Lumen Method. So this is the latest and currently we use this method lah for calculate the lighting required for every room. So the level of illuminant is placed such as industrial workroom and office are usually prescribed in terms of average illuminant and horizontal working plane. To design lighting scheme that will produce desired level of illuminant, the quantity of illuminant must be determined. Okay, so we use this formula, which is N is the number of luminae. So this one we need to find kan. And then we have EAV. EAV is average illuminant ataupun very simple to remember, this is the lux value. So lux value I already share with you. Okay, I open back. Okay. Okay, I try to open sample of illuminant. Kenapa hilang habis ni? Saya punya ni. Okay, lux table. Okay, this is I believe all of you already downloaded it. Okay. Okay, this is the table of lux, illuminant table. So from here, you need to find, let's say you got the project after this. Then let's say you have the director room ataupun whatever lah. So you need to find the building area ni. Okay, general building area. And then you find same function lah, same function. So you need to find one by one lah. Okay, we have a lot of room. Okay, metal, wood, office. Okay, let's say we have office here. Deep plan general office, business machine type, filing room, conference room. So for the what we call it, the director, normally we use executive office lah kan. Executive office. And then, okay, we can see here we have IES and JKR standard. It depends on you. You want to use which one standard, either IES or JKR. But for me, okay, I will refer to the JKR. But it depends on the project type. Normally, the government building, which is supervised by JKR, so confirm they will use JKR standard. But for private building, so you can use the IES standard. Or maybe you working outside from the Malaysia, so you can use this table because this is the standard of international. So you can use the IES standard for calculation of lux. Okay, so let's say for this office, executive office, so following to the IES, they use 500, but JKR only 300. So that's why you need to decide first. Okay, you want to use the JKR or you want to use IES. Don't combine. Okay, make sure don't combine. You just standardize for all of your project. Let's say you decide your project will use JKR standard. So you use all calculation using the JKR standard. Okay, clear? Clear for lux table. So on how to select. So we referring to the director room tadi lah. Okay, just now. So we select 300 and then you see position of the measurement. So position of the measurement, this is the level working plane. Okay, so for this room, it directly told us this is depend on the desk. So it just told the desk. So we need to know lah what does the value of the desk height kan. That's why we call it 0.7. And then possible need to vary lighting using dimmer. So this is the what we call notes lah. Maybe you want to use dimmer to control. Maybe sometime because this is the executive kan. So some executive they want very privacy and so on. So you can provide the dimmer to him for this room. Okay, this only note lah possible saja. Kalau you talk if you not provide also can, no problem. But the important thing is this one, this value and this one, because this value of a working plane will affect the value of the height during the calculation of value of room index tu. So based on this one, kan? Kalau this one is board, so which board you need to know lah. Board mana kan? Nak kena refer di mana. Okay, clear on this table, lux table is there any question if you want to ask related to the lux table on how to use lux table? Kamu boleh tanya, you can ask me if you don't clear on how to use the table. Okay, settle lux table, and number 2 is length and width. Length and width is same lah, you just measure lah. Let's say you open this room kan, let's say this room, okay, you can use the dimension, you just measure, but this thing we will cover on lab tomorrow or this week lah. I hope Mr. Faizul and Cik Zam already covered lah for your group. For my group, I will teach on Friday. Okay, on how to determine the dimension for every room. Okay, so we measure from here to here for length and from here to here for width. So you got it. Okay, the value for length and width. And then we divide by LDL. LDL apa ni? LDL is the initial lumen of each lamp obtained from manufacturer data multiplied by number of lamp in each luminaire. Okay, LDL, you need to find it. Okay, it depend. LDL is lumen. Normally we call it lumen. So how? What value for lumen? So I already share to you also the lumen table. Okay, and this is the sample sample. And normally JKR will use this LDL. Let's say you use 2/16, 2/18 watt. Okay, TLD standard fluorescent kan. So the lumen is 2100. And this is the LDL value. Very simple kan. It depends on type of lighting that you use in your project. Okay. So let's say you use downlight. So the LDL is 1000 for one for one light, one lamp. Okay, and the best thing to find this value is you can open before I already prepare lah. Ada tak sini? Okay, this one is tak kena. Let's say you want to find the value of a lumen, you can open, you can search. Okay, let's say you want to use this Philip product. Okay, you just find on the Google, because we need to find what does a exact value of the lumen from the lighting that you want to use. So let's say you want to use this 36 watt of TLD, so you can find from the product data, and then you just scroll down and then you try to find the lumen value. So you can see here, boleh nampak tak? Siapa guna handphone memang tak nampak kan. Okay, so here you can see that the value for this lamp 36 watt is 2500 lumen. And for your project, I will ask you to have or to download all the appendix that you want to use for your project. Okay, so jangan don't easily just use this JKR punya standard ni. This one just a guide. Okay, just a guide nah. Okay, for this one let's say TLD 1/36 is 2500 kan. Same, we got the same value, right? 2500, same value, but for your project you must have this data sheet into your project report. You must include it. Okay, because we try to learn on the actual project. Let's say you want to design the lighting, so confirm you need to have a real one. If you just use the JKR standard, so let's say you have a complete design, and then when the time for the installation of the lighting, so can you imagine what will happen? So the contractor will not know what does which one a bulb or light that you want to use. So that will be the issue lah. So that's why for your design, whatever component that you want to design, you need to find in a real things. Okay, so for this bulb, for this fluorescent, so you download it and then you use the value from here for your design. Okay, clear the lumen. Ada siapa-siapa nak tanya soalan ke? Ke mic tu, saya tak nampak ni. And then clear on LDL, clear? Semua boleh cari value of LDL. I hope all of you clear every part on this topic, on this method lah, because your project you will use this method. Okay, then we move to the COU. Okay, ada soalan ke? Saya dengar. Okay, COU, what does it mean? COU is a coefficient of utilization factor. So faktor kepelbagaian lah. Faktor how many number of use of this lamp. So we need to consider also how many time it open off of the lamp. So we try to consider, because normally we don't use the lamp for every time, right? So we need to calculate COU. So COU it depends on the room index. It depends on the room index. Okay, how to find the COU? Okay, so to determine value of the COU, we need to have the data sheet again. So it have two method. Let's say from here we have from JKR. If you can see from this table, this is table for COU lah, COU. Okay, you can see here ceiling, wall, kan? This is ceiling, wall only. Okay, JKR only consider ceiling and wall. And then from here, you will have 50, 30, and 10. Okay, clear? And from this value, we select, let's say you want to use which type of lamp. Okay, this is let's say you select this model. Okay, so the value of ceiling is 70, and then 70 is a fixed. Okay, 70 is white lah. And then the 50 is white, 30 is darker, and then 10 is darkest, like that. So meaning that this wall is painted by the white color, and the last one is painted by the black color. So you need to know about it. Okay, so the ceiling 70 white only. Okay, jika use 70 only. Okay, let's say 70, 50. So let's say white color. Okay, so we just use refer to this column only. So this column, okay, so now it depends on your calculation of the room index. Just now you have calculate, you dapat apa tadi? You calculate 1.6 kan? Right, 1.6 right? You calculate room index just now. So 1.6 you need to use 2. And then from 2, you can select value of COU is 0.6 for your calculation. And this is how to use the COU from JKR. Okay, clear? Faham tak? Faham tak on how to use? Clear? Okay. Number 2, we have another thing which is the correct way on how to determine, because JKR just give a guideline. We can use it for if you don't have any data sheet and so on. But in your project or in real life, you need to use a real thing lah. Okay. So to determine the COU, let's say you want to use this light, this model lighting. Okay. This is one example lah. You need to download. You need to have the data sheet of the lighting. Okay. To determine value of COU. Okay, first step, you already calculate the room index, and then from that, let's say you decide to use 2x36 watt of lighting. Let's say, okay, you want to use this model, and then you go to the next page. You will find the polar curve of the lighting, kan? You nampak kan? This polar curve. And then you just scroll down and then you'll find the utilization factor table. Okay, this part. This is the important part. Nampak tak? Okay, nampak? Saya kena zoom lagi. Okay. Okay, now it said, okay, from here you can see this is the room index. Kan? Room index, that value you already calculate. And all of this one, okay, this is the value of COU, which is utilization factor. Okay, how to read it? Okay, same thing lah. Okay, in the real one, it consider 3 things: ceiling, wall, and floor. What does it do? This is value of color. Okay, color of ceiling. Okay, 0.7 is white, 0 is black lah. Okay. So let's say the ceiling is a paint by color red. So which one you want to use? 0.7 or 0.3? Agak-agak lah. Okay? Agak-agak. You need to consider, at least you know the range. 0.7 is white, 0 is black. So on between on that, you can consider lah. Yeah. I think red is more to the darker, right? So you can use 0.3. And then maybe light blue, so you still can use 0.5. Okay, this is on how to determine value of the reflected. And also same with the wall and floor. So the highest value shows the lighter color. Okay. And the lowest value shows the darker, gelap, makin gelap. Okay, this one very white. This is the black color. Clear? So we consider back the value from room index that you already calculate, which is you got 1.63, right? So 1.6. Okay, you can see this value. So this upper one, okay, you must select bigger than, okay, bigger than whatever value that you have calculated. Okay, let's say you have calculate you got 1.6, so we cannot use 1.5 anymore, so we need to refer to 2 lah, value of 2. Kan? And then let's say we consider the color of ceiling, wall and floor in white color, so this level. So the value of COU we can get is 0.64. Okay, clear? And there's not much different. So JKR 0.6. This one is 0.64. Okay, this is on how to determine the correct way of the COU value. Faham eh? Okay, nanti after this, if you works on consultant or contractor and so on, if you are able to read all of this data sheet, so your boss will be very happy with you lah. Believe me. Okay, I just teach you what are the real things, and whatever I'm before this I'm working as a engineer and consultant, and this is my work. Whatever I have done, I just share with you lah. Okay, before this nobody will teach me, so I just teach you all. Okay, clear on COU, and then lastly is maintenance factor. Okay, so maintenance factor normally we use the standard value, which is 0.85. Okay, maintenance value meaning that maintenance factor we consider every lighting that we install, confirm it will have some time to maintain it, right? Okay, so normally we use 0.85, and this value are standardized on JKR by the JKR. For international, sometimes they use 0.8, sometimes they use 0.85. So it depends, and you can ask them. You can ask the standard. Maybe some company they use 0.85, some company use 0.8. So maybe for the first time when you are working, you can ask them. So in our company, what value we use for maintenance factor? You tanya tu soalan tu kat bos kamu pun boleh. You can ask your boss. Okay, but my suggestion you can straight away use 0.85. So once you have complete all of this value, then you can have the exact value or the requirement value of the lighting for specific room. Okay, clear. Then in order the room that we have considered room index, reflector, and so on. And what I want to share is, please don't confuse with the LDL and the what we call it, the reflector. Most of the student confused about it. Okay, confuse apa yang saya nak cuba sampaikan adalah just now I have share, right? Okay, this one is the reflector. Reflector kamu pasal? Nah, this one. This is we call it reflector. Reflector or casing of the lamp only. It not complete with lamp. The lamp value for lamp, this one. Okay, this one value for lamp. Bulb dia, the bulb. Okay, this is the bulb. So two different things. Maybe right now you not tak faham kat mana nak guna kan. So once you have perform your assignment, perform your project report, you calculate, so you will find, or you will confuse after this. So that's why I just remind earlier. Okay, so LDL must refer to this specific. Okay, compare back to formula. Okay, mana dia? Hilang dah. Okay, This LDL, you must use this one, this value, LDL. Okay, LDL. And then COU, for COU, you use this data sheet. Okay, this table. So, okay, so in order to find a value of the lamp, LDL, and the lighting, okay, you must check the size of the model. Let's say you want to use this 2 by 36 watt, right? So meaning that you have 1 and 2 bulb here. You must know, you must understand whatever. Okay, 2 by 36. And then you refer also the size of the casing, 600 by 600. And then you check back with the data sheet, what does type, what the length for this model. Ada tak dia bagi? You need to check detail lah, because okay. Okay, here you can see from here. B, right? B. So B is 1206. So meaning that this bulb cannot be used on this one because this one is 600. Okay, so you need to find a correct lamp that which is possible to install into the casing of the lamp. Okay, understand? I hope you understand lah, because this is the most mistake that has been done by your senior lah. So that's why I'm talking to you directly. Maybe you can use it for to perform your correct project lah. To a correct project. Okay, you are become a electrical designer after this. So okay, and then okay, we try to finish it. Mana slide ni? Okay. Lighting design. Okay, oh, I forgot one thing. Okay, after you complete, let's say you calculate your calculation, you got what we call it, you got 10 kan, 10 numbers of the lighting. Let's say you calculate, you got 10 numbers kan, 10 numbers, and then we need to uniformity of the illuminant. So uniform tu maksud the arrangement of the lighting into the room. Let's say this is your room kan, let's say this is your room. So you have a 10 numbers. Okay, we calculate, we got value of n is equal to 10. So from the 10, how to adjust, how to arrange into the building, into the room. So you can use 2 by maybe 5 here kan, 5, 3, 4, 5. So you can use 2 by 5. So confirm you got 10. Or maybe you got different. It depend on the size. Maybe you can arrange 5 by 5 kan, 5 macam ni, 5, 3, 4, 5, 5 to 5 also can. So the arrangement. So how? So you must calculate. Okay, it's determined by the luminous intensity distribution polar curve. Its mounting height above the working plane. Okay, the dash height. Okay, 0.7 to just or 0.85 for industry. Okay, let's say you got the room at the industry, so the level for the dash is 0.85, not 0.7. And then spacing for height ratio is spacing between the center of the luminous divided by height above the working plane. So you need to calculate. Let's say for this case, okay, so this is the height that we consider in our calculation. Okay, and then this is a value of space that we need to calculate. Okay, in order to uniform kan, we want to arrange that numbers of lighting we have in uniform lah. Tak nak lah this one is very near and then it's too far. So your design akan nampak very bad, kan. As a designer, you want to have a very smooth, very good design. So that's why everything is ready here. So we need to calculate a little bit. So how? So let's say, let's say and this one give the example, kan. So the formula is SHR max is space divided by height. Okay, so height. Okay, so SHR max we already know. How to know it? We refer back to the data sheet. If you can open back your data sheet, okay, the COU level, okay, you can see here. You check this one. This is the value for SHR max. So here value SHR max is 1.65. So you can use here 1.65. Clear? Make sure you select the correct SHR max lah. Kan 1.6. So for this case 1.4 use, kan. So height, to determine height, you just divide lah. 3 minus 0.7, you got the value. For this case, just this example lah. So 1.9, so they get S equal to 2.66. When they get the value for 2.66, so they can arrange lah. So let's say for this lighting, first lighting, and for the second lighting, we have this space, okay, center to center, center to this center, this value you can use. And then this lighting for another lighting, same value 2.6. So when we have this value, confirm your project, your design will be in uniform lah. Keadaan yang very same distance, kan, very uniform, complete in your design. And then for the last one, okay, the last, this, let's say this is your wall. So the last point we just use S over 2. So the setengah ya, only half. Let's say we have already 2.66, so we just divide by 2. We get the value is 1.33. The last one, okay, the last one. And then also this one, this wall. Okay, 0.5, half. Okay, if the spacing height ratio exceed, okay, the value that we have get from here, this is the maximum now. The value, we call it SHR, okay, max, maximum value. So meaning that the location that you need, you want to place this lamp from lamp 1 to lamp 2, this is the maximum number. Okay, let's say you have 10, kan, you only have 10 meter, but you calculate, kan, if you use this value, it's more than 10, kan. So how you to allocate? So you must bear in mind that this is value for maximum. So you need to put it in dekat sikit lah, kan, near it. This is guideline for us that this is the maximum you can put the between of two lamp. Okay, but you need to consider the room size lah. You cannot simply, okay, you calculate 2.6, so you just put, okay, let's say we have 5 here, you have 5 lamp here, 2.6 multiply by 5, we got more than 10, right? So more than 10, and then you only have 10 meters, so how to allocate? Maybe you can put only 3 lamp. So the another 2, where to put it? Just so you need to arrange back lah. Okay, arrange. This is the value for maximum. Okay. And it should not less 80% illuminant. So this why we need to calculate the S value space. Kan? If we not calculate the S, let's say we calculate value for just now, we got 2.66, right? 2.66, let's say this one, okay, from point A to point B. If we arrange is 4 then 2.6. Okay, let's say 2.6 kat sini je. Okay. From here to here, it's become 2.6 only, kan? So already this is maximum. So that's become like that lah. So that's why this desk will not have a complete lighting here. So this area will be dark lah. So you say reduction of illuminant on the working plan. So if you use a correct number of 2.66, so you will get this one. So this area will got the lighting. Okay. And then this is the SSR mark and SSR max TR. This only applicable for symmetrical intensity distribution. So katakan ruang tu you got the space is not symmetry. So you can use the guideline which is SSR max TR. So this condition you must consider 3 conditions you must comply, which is space on transverse direction TR must not exceed SSR max, and then spacing axial direction must not exceed SSR max, and the actual spacing in 2 direction SSR axial and SSR transverse when multiplied together must not exceed SSR max squared. Ini ya. So the value that you apply must not exceed the what we call it SSR max. Okay. So this is jarang-jarang berlaku lah. Okay. Okay, clear. So this not quiz. Okay, I will not consider quiz lah. This is just for your exercise. Okay. We have time kan? Another 4 minutes. Okay, we can try for this example. So let's say we have office given 500, okay, and then working plane 0.5, okay, we have a table, and then the office dimension it gives to us 10 multiplied by 6. Okay, and then ceiling height is 2.68 and pane white. And wall have light finish surface. Room, okay, is give us also. So from this, can you determine the total number required for this room, for this office? Okay, try calculate before we end our class. So attendant link I already share. So you can use it. So try calculate and someone try to give the answer, and then we can stop the class lah. We can end our class for today. Try to calculate. I want to know how many number of lamp required for this room, for this question. Very simple. Okay, maintenance factor 0.85. Okay, okay, and also at the end you can try by your own lah the spacing arrangement. Use ladder. Okay, data sheet I put this link. You can try to refer it. Okay, somebody try to calculate. So first step is you calculate the room index. Okay, room index. dapat berapa? Dia siapa-siapa calculate tak? Room index. So room index, very simple formula. Length multiplied by width divide by height multiplied by length plus width. So we have 10 multiplied by 6, we have 60 divide by height dia 2.68 minus 0.75, we got 1.69 1.93 multiplied by 16 kan, multiply by 16, so 60 divided by 7, so you got berapa you dapat room index? 1.4 1.4 bukan 1.94.
1.94.
Okay, good. So now you already have the room index. So after that, so what you should do is kan, we refer back to the formula. Sekejap, saya open this datasheet first. Okay, so we can calculate now the sama-sama tu you calculate kan, kalau dah siapa dapat kan. So n equal to lux kan, so lux dia bagi is given 500 multiply by 10 multiply by 6 divide by LDL. So LDL berapa ni? So that the issue kan. So LDL we need to refer. So let's say for this case, we need to refer JKR standard lah. LDL table 2/18 kan. So 2/18 is 2/18 here 2100 because it use 2/18 kan. So 2000 2100 multiply by COU multiply by maintenance factor is 0.85 kan. Dia bagi dah. So COU we got 1.94 room index, and then we refer to datasheet yang dibagi ni. Mana dia tadi? Okay, 2/18 okay, the ceiling, wall and floor 0.7, 0.5 and 0.2 kan. And then we calculate, we got 1.93 kan. So 1.9, so confirm we need to refer at this value 2. So the value for COU is 0.66. Okay, so dah dapat dah. Berapa ni? 0.66 kan. Tekan calculator jap, dapat apa? Number dia. So number berapa dapat? Everything is there. 500 multiply by 10 multiply by 6 divide by 2001 multiply by 0.66. Berapa dapat?
25.46.
25. 25.46.
46.
So this value, can we consider the number for n? Cannot lah. Kan? Macam mana you nak install 25.4? So you need to bundarkan lah. Okay. So to become 26. Kan? 26 is the real number, because you want to install the real number of lighting, kan? So if you only have 25.4, 0.4 tu you nak dapat macam mana, kan? So when you just up to 26. And must remember, you cannot reduce it. Let's say you get 25.4 or you reduce to 25 only, cannot. You must increase it. You must increase because this is the minimum value of lux that you calculate. So kecerahan yang sepatutnya dapat dalam bilik ni is 25.4. So you cannot reduce it. You can improve it. Okay. 26, and then from 26 you can try to arrange to make uniform in the building. So I believe that if you got 26, you cannot arrange into this room, kan? Kalau 26 macam mana you nak arrange? How could you arrange 26 in this room? Can or not? Tak boleh, kan? 26 you nak susun macam mana? Kan? So if you cannot arrange that situation, so you can find the what we call it, maybe you can up to 28 lah, kan? 28 divide by 3, you can 27 increase up to 27. Okay, because 27 you can have 3 by 9, kan? So you have 1, 2, 3, and then this one up to 9 9 column. 9 column divide by 3 row. Ataupun saya terbalik. 3 row, betul? 3 row by 9 column. So you got 27. And then you need, after that you need to check by calculate the SSR max tu, kan? So SSR max you can calculate using the equation S equal to lah, SSR max, kan? So from that you can get the spacing between two lamp, how many number. Is it possible ataupun tak dengan arrangement that you select to use. Okay, so I think this is the last slide. So I end up to this slide. I open to the floor. Is there anything that you want to ask? Ada apa-apa nak tanya tak? Kalau tak, if not, I consider all of you got something for today, and you must remember and you must clear on this topic due to calculation and for your project. Share the slide tak? Dalam Google Classroom tu tak sama ke? Lain
ada lain sikit. Betul.
Oh, ada lain Okay. So, sekejap saya share slide ni. So, sorry for the first 30 minutes that a lot of technical problem. And then try to make exercise related to this work. Let's say I give some you can use your lab lah. You can use your lab, kan? In your lab you have the drawing, right? So based on that room you try to calculate in real. Is it you can calculate or not? If you have a problem, please clear it this week only, because start from next week you need to perform your project. Okay, and a lot of a room you need to calculate. Okay, if you got problem, so confirm you cannot solve, you cannot perform your project, you cannot finish your project. Okay, so that's all for me today. See you on tomorrow lah, tomorrow evening too, kan? So tomorrow I will explain on what we call it, the type of lamp and also on how to perform to the project lah for the lighting. Okay, so that's all. Thank you for your attention for today. Thank you. Don't forget to fill up the attendance.
Sir, boleh bagi sekali lagi link?
Link attendance ke? Sekejap, saya dah hilang habis dah. Saya kena buka balik. Ada siapa-siapa yang ada tak link tu? Attendance hari ni Hari ni week 3 kan? Week 3. Okay. Tu. Thank you Akmirul, Akmal, share. Okay. Thank you.
Thank you, sir.